talking about today is sound and the Doppler effect.
Yes.
Okay. That first equation is for the frequency produced by a string, and its frequency equals n, which is the harmonic number, and almost always it's going to be equal to 1, unless it says like second harmonic or third harmonic. If it says fundamental frequency, that means 1 as well. V is the speed of the wave in the string, which is you will usually have to be given, and then over 2 times L, where L is the length of the string. Does that make sense, everybody? Okay, next one is for a pipe open at both ends. So again, like that's a flute from the notes. And same thing there, except this time V is the speed of sound in air, and L is just the length of the pipe, and N is the harmonic, and it can be 1, 2, 3, 4, 5, 6, any whole number. Yes.
What was V in the first one?
V is the speed of the wave in the string. So like this is like a guitar string, it's how fast the wave would move in the guitar string.
V is the speed of something, pretty much.
V is the speed of something, yes.
So velocity.
Velocity. Abby?
Just to clarify for N, it's usually going to be 1, but if it says, like for number 1, it says the second harmonic.
Then it would be 2.
Okay.
Yep.
Okay.
Alright. And number 4, for pipe closed at one end, the it's the same deal except it's over 4L, and now N can only be 1, 3, 5, so on. So it can only be an odd number. Does that make sense to everybody?
What is V for that one?
Speed of sound in air still. Okay, next equation is for the beat frequency, and what this is really used for is like tuning stuff, and we'll talk about that when we get to the some of the questions here. And that's the beat frequency here is just the absolute value of the difference in the two frequencies. So if one is 340, one is 341, the beat frequency would just be 1. It's just the difference. And that last one is the Doppler effect equation. And the regular F is the frequency you hear. The F sub O is the frequency that's produced. So like if you're hearing like a car drive by you, F sub O would be the frequency that you'd hear the car if everything was standing still. Does that make sense? The V, like just V is the speed of sound in air. And again, if it doesn't tell you what the speed of sound in air is, just assume it's 340 meters per second. It changes based on temperature, but what?
What was that?
The just V is the speed of sound in air, and assume that it's, if you're ever not given it, just assume it's 340 meters per second for the speed of sound in air. And then VO is the speed of the observer, and VS is the speed of the sound source. So for like a race car, if the race car is coming toward you and you're standing still, you're the observer, the race car is the source, so the V for the observer would be 0, and the race car would be however fast the race car is moving. And VO and VS are positive if you're moving toward the source of the observer, and negative if you're moving away. Does that make sense? So if the car is driven past you, you make VS negative. Any questions about that? Right, let's do number 1. What is the length of an open pipe in which the second harmonic has a frequency of 3,180 hertz? The speed of sound is 346 meters per second. Okay, so which equation are we going to use? F equals N V over 2L. So what do we know here?
Frequency is 2.
Frequency is what?
3,180 hertz.
What's N?
2.
2 since the second harmonic. And then the V?
346.
346 meters per second.
Yes.
Over 2 times L, which is what we're looking for.
That's
You can cancel the 2's though, right?
You can cancel the 2's because it's 2 over 2. So we get 31, 80 hertz equals 346 over L. What do we do with that L? Here. Switch. So we gotta multiply both sides by L, right?
Yeah.
So we get 3180 L equals 346. So what does L end up equaling?
0.1.
Does that make sense to everybody?
Is that the answer?
That's the answer. These problems are not very hard in this section, which is why we're going to squeeze this test in before spring break.
What?
I love that. What?
This is the last section of the math for you guys here.
Oh, really?
Ever?
No, whatever.
It's what we did yesterday and today, and that'll be it.
That'll be it.
Group quiz?
We'll probably have a group quiz at some point this week. Okay. Anybody have any questions on this one? Okay. Alright, this next one, I don't even do math on these. So it says 2 notes are sounding, one of which is 369 hertz. If a beat frequency of 4 hertz is heard, what is the other note's frequency? So the beat frequency is just the difference between the two frequencies. So there's 2 possibilities for this one, for what the other frequency would be. So you add 4 and subtract 4. Doesn't matter which one you do. Usually I'll ask you for both, but this one is, it's either 373 or 365 hertz. Anybody have any questions on that? Again, the beat stuff is pretty easy usually.
So you just say one of those, or you say both?
That's
of those?
alright.
I'd say both of those. Okay. Number 3. The sound source is moving away from you at 30 meters per second. The frequency you hear is 430 hertz. What is the frequency of the sound being produced? Assume that the speed of sound in air is 340 meters per second. So we have F equals FO times V, should write it down here, plus VO over V minus VS. Okay. The frequency we're given is which F? Just plain F. So what was that? We have 430 hertz equals FO, which is what we're looking for, times 340 for the speed of sound in air. What's the speed of the observer here? 0. Plus 0 times divided by 340 minus 30. Is it away, toward or away from?
Away.
Away, so it's going to be
Minus the minus.
minus 30.
minus, yeah, so minus, does that make sense why it's that?
So if it was moving toward you, it would be just minus 30.
It would just be minus 30. So we end up with 430 equals FO times 340 over 370. So it's 3 and it was 340 over 370.
0.9.
So FO is going to equal 430 divided by 0.92.
467.
Any questions on that one? And that makes sense because the frequency that's being produced is higher than the frequency you hear. So when something's moving away from you, you're always going to hear a lower frequency. When something's moving toward you, you hear a higher frequency than it would be normally. Does that make sense? Questions?
Yeah.
Yes.
Alright, can frequency ever be negative?
Frequency's not ever going to be negative.
So the answer is always gonna be positive.
It's always going to be
So if you
positive.
get a negative answer, you know you did something wrong.
Well, if you get negative, what a negative answer would mean here, what would have to be the object or the source have to be moving faster than the speed of sound, which means you're just not going to hear it.
Yeah.
So like if there's a truck that's moving away from you faster than the speed of sound, you're not going to hear the sound from that truck. Right. Any questions on these?
I got a question for you.
That's Michael.
So, will it specifically say it's closed on one end so we know when to use before L?
It'll specifically say it's closed at one
So
end.
that's the only time we'll use it?
Yep.
Okay.